Okay, now for this one, momentum is just going to be mass times velocity, remembering P is a symbol for that. Now, Fernando's mass is 50 kgs, so we put that in, and his velocity from the diagram is 9.1 meters per second. So if we times those two together, we end up with 455. Now, the units you can get from the question, which is just going to be kilograms, meters per second. Okay, so that's the first one. That's only worth an achieve. But this next one's going to be worth a lot more. That's kind of like worth a excellence. So we're going to get, now because the other player was stationary, this is the total amount of momentum. I'm making some assumptions here that momentum is conserved. There are no external forces acting, so that's going to be equal to, now obviously he hasn't lost weight in the process, so it's going to be 50 kgs times whatever this velocity is of Fernando, which is times 5.2 meters per second. So 50 times 5.2. Better put it out properly because I'm going to include the other player, which is what we want to calculate, which is going to be 56 kgs times whatever velocity he is at. So if we multiply 50 times 5.2, we get 260. So 455 equals 260 plus 56v. So anyway, so if we move the 260 over, we're going to get 455 minus 260, which equals 195 equals 56v. And then if we divide 195 by 56, that should give us v. So, and that equals 3.48 meters per second, and it is to the right. It's positive, so we can see that to work this out we haven't had to change anything, so it means it's in the same direction that Fernando was heading. Okay, so if you get that including the direction, that is worth an E. Alright. Now, the assumption you made, which I mentioned before, just change to get a prettier colour, is that momentum has been conserved. Now, if you recall, you can only make that assumption if there's no external force operating on it. So, assume no other external force acting. That could be friction or gravity or something like that. Okay, so it's just being aware that there are assumptions we make with those calculations. That would only be an achieve, I would think, in that case. Okay, in this next case, we're talking about the average force that's exerted on a stationary player. And we've got a time here. Now, if you look at your formula, you'll see this one, change in momentum equals force, and it's times by the time that it's acting. Now, impulse can happen, this can happen in systems that are closed and that conservation of momentum occurs, as in this case, or when an external force acts and momentum isn't conserved. Impulse isn't equal to an object's momentum, but it's change in momentum. So the total momentum was 455, and it still has 260 afterwards, Fernando does, which means that there's been a loss of 195 in terms of change of momentum. So that's a change of momentum. It's important to get that one right, that you're putting the change. Okay, so if you recall, that was his total amount. This is the amount that he had afterwards, and therefore this is the change of momentum. That's going to equal force, which is what we're looking at, times by time, which we've been told is 0.65 seconds. So 195 divided by 0.65 is going to be the, basically the average force. So we're making some assumptions over that time. And that equals 300 newtons. Didn't think it would equal an even number. Anyway, that one's worth a merit. And I had a little look at this one previously. And if you were to make both statements, that would in fact be a merit. Okay.